Welcome back to AI.Code.Cast, your daily dose of coding challenges. Today we're going to be diving into a problem that you might encounter in a technical interview. It's called flip columns for maximum number of equal rows.
Oh, yeah, this is a fun one.
So imagine you have a grid, like a spreadsheet or something, but it's filled with only zeros and ones.
Okay, got it. Like a bunch of light switches.
Yeah, exactly. Where a 1 means the light is on and a 0 means it's off. Now here's the twist. You can flip entire columns at once.
So it's like having a master switch for each column.
You got it. And the goal is to figure out how to flip these columns so you end up with the most rows where all the lights are either on or off.
Right. So you want to maximize the number of rows that are all the same. Interesting.
So what are some of the initial thoughts people might have when they first see this problem? Like what are some of the maybe the traps they might fall into?
Well, I think a lot of people, their first instinct is to just try every single combination of column flips.
Yeah, just brute force it. Just see what happens.
Exactly. It's kind of a brute force approach. Check every single possibility. But the issue is, as the grid gets bigger, the number of possible combinations, explode.
Yeah, it gets out of hand pretty quickly.
Oh, yeah. It becomes incredibly time-consuming and frankly, practically impossible for really large grids.
Right. So if we're talking about, a grid with thousands of rows and columns, brute force is just not going to cut it.
Exactly. We need something more efficient.
So there's got to be a better way, right? There's got to be some kind of trick or strategy we can use to solve this without resorting to brute force.
Absolutely. The key is to think about patterns.
Patterns. Okay, I'm intrigued.
Yeah, instead of just looking at each individual 0 or 1, think about how the entire row relates to other rows.
I see. So recognizing similarities or relationships between the rows, even if they're not identical.
Precisely. And once you start thinking in terms of patterns, a couple of really clever approaches emerge. One is called the HashMap approach, and it starts by doing something called normalizing the rows.
Okay, normalizing. Now, I'm not totally familiar with that term. What does that mean in this context? What are we doing to these rows?
So normalizing essentially means making sure all the rows start with a 0. If a row starts with a 1, you just flip all the bits in that row.
Oh, interesting. So we're kind of standardizing the starting point for each row.
Exactly. This way, rows that could become the same after some column flips are treated as the same from the start, even if they look different initially. For instance, the rows 1, 0, 1 and 0, 1, 0, they become identical after you normalize them.
So by normalizing them, we're revealing this underlying pattern that wasn't immediately obvious.
Right. And that's where the hash map comes in. It's like a way to group similar items together. So you treat each normalized row as a key in this hash map, and then you store the number of times you've seen that specific pattern.
So the hash map helps us count how many rows share the same normalized pattern.
Clever.
Yeah.
Can you give me a concrete example? Sure. Let's say you have the matrix. 0, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, and 0, 0, 0. The third and fourth rows start with 1, right?
Right.
So we flip all the bits in those rows during normalization, and what do you notice?
Well, it looks like after normalization, we end up with 4 rows that are all 0, 0, 0.
Exactly. We revealed a hidden pattern. With the right column flips, 4 out of 5 rows can become the same. And we didn't have to try every single combination to find that.
Wow. That's way more efficient than brute force. So that's the power of this hash map approach, right?
Precisely. But, there's another way to do this. It's called the bit manipulation approach. And it kind of builds on this idea of normalization.
Okay, bit manipulation. Now that sounds even more hardcore. What's the idea behind that?
So instead of storing the entire normalized row in the hash map, we represent each row as a single integer.
Wait, a single integer? How's that even possible? How do you cram all that information into one number?
Well, that's where the bit manipulation magic comes in. We treat each bit in the row as a bit in an integer.
I see. So since our input is only zeros and ones, we can essentially encode each row as a binary number. Super space efficient. But how do we account for the fact that rows could become the same after flipping some columns?
Good question. The trick is, after normalization, the rows that are either identical or are inverses of each other, well, they can actually both be transformed into the same pattern with the right column flips, like 0, 1, 0 and 1, 0, 1. They can both become 0, 0, 0 if you flip the right columns.
Interesting. So we only need to consider one of those representations. Clever. This is getting pretty deep.
It is, and it's especially useful for larger matrices where saving memory is crucial. So we group these kind of equivalent rows together, and that helps us figure out the maximum count even faster.
Okay, so both the hash map and the bit manipulation approach, they seem light years ahead of brute force, and they both rely on this idea of normalization. But is one, like, definitively better than the other? Is there a clear winner?
Well, it depends. The bit manipulation approach is definitely a champ if memory is a big concern, since it uses less space by encoding rows as integers. But, the hash map approach might be easier for some folks to understand and implement at first. It's a bit more intuitive in that sense.
Right, so there's a bit of a trade-off there. But I'm curious, are there any weird situations or edge cases that we need to be aware of? Like, what happens if the input matrix has only one row? Do these approaches still work?
That's a great question. And it shows why thinking about edge cases is important. Yeah, they both handle it just fine. If there's only one row, well, the maximum number of equal rows is obviously one. And if all the elements are already the same, well, you're already done.
Right, no need to overthink it in those cases. It's pretty cool how those solutions just, like, naturally take care of those edge cases. But I'm curious, why is this problem so popular in coding interviews? It seems kind of specific.
Yeah, it might seem that way at first glance. But, it really tests a lot of important skills that are super valuable in software development. Like, first of all, problem solving, right? Can you analyze a problem, break it down into smaller pieces, and come up with a solution that actually works?
Right, it's not just about getting the answer, it's about the process.
Exactly. And second, it shows that you understand data structures like hash maps. And more importantly, can you use them effectively to solve a real problem?
So it's not just about knowing the theory, it's about applying it.
Exactly. And then third, it shows that you get bit manipulation, which can be a really powerful technique for optimization in a lot of different areas.
So interviewers are looking for someone who can think beyond just, like, the basic solution, right? Someone who can come up with something clever and efficient.
Absolutely. They want to see your thought process, how you approach a challenge, and how you can reason through different possibilities.
Yeah, makes sense. This deep dive has been super insightful, by the way. I mean, we started with what seemed like a pretty straightforward problem about flipping columns in a grid, and we ended up exploring all these cool algorithms, data structures, and optimization
I
techniques.
know, right? It's amazing how much you can learn from like a seemingly simple problem.
It really is.
Yeah.
And what I find really fascinating is that these techniques, they're not just limited to this one specific problem,
Yeah.
right? I mean, pattern recognition, efficient data structures, bit manipulation, these are all fundamental concepts that are used everywhere, from image processing to machine learning. It's like they're transferable skills.
Absolutely. That's one of the best things about computer science, in my opinion. You learn these core principles and you can apply them to a huge range of real-world problems.
Exactly. It's so cool. Before we wrap up, I have a kind of a final thought. We discussed the hash map approach and the bit manipulation approach, and they're both really elegant solutions. But I got to ask, is there an even better way out there? Like, could there be a more efficient solution? Or maybe a more intuitive one that we haven't even thought of?
That's the thing about computer science, there's always room for improvement. There's always something new to discover. Maybe there's a totally different way to think about this problem or a more subtle pattern that we haven't uncovered yet.
Yeah. Or maybe we can take these techniques and apply them to other problems, right? Because pattern recognition and optimization, these are universal concepts.
Totally. So, we challenge you, our listeners, to keep exploring. See if you can come up with an even better solution, or maybe try applying these ideas to a different problem.
Yeah. Keep that curiosity going. And if you come up with something amazing, share with the community.
Definitely. Until next time, keep coding, keep learning, and keep pushing the boundaries of what's possible.
And that's a wrap on this deep dive into flip columns for a maximum number of equal rows. We hope you enjoyed it as much as we did.
Happy coding, everyone.
It really is. It blows my mind how we can learn something from a problem like this and then apply it to, like, completely different areas.
I know, right? It's like a superpower. Once you unlock these skills, they become part of your coding arsenal.
Exactly. So to all our listeners out there, don't underestimate the power of a problem like flip columns for maximum number of equal rows. It's not just about solving this one puzzle. It's about gaining those core coding skills like pattern recognition, optimization, and mastering tools like hash maps and bit manipulation. Those will take you far.
Couldn't have said it better myself. And who knows, maybe you'll even discover an even better solution, something we haven't even thought of yet.
That's the beauty of coding, right? There's always more to learn and explore.
F.
Well, that's about all the time we have for today's deep dive into flip columns for maximum number of equal rows. Hopefully you all learned something new and you're feeling ready to tackle this problem, or any problem really, with confidence.
That's right. Happy coding, everyone.
Until next time.